myself, and we'll hopefully get it going. So without further ado, I'd like to introduce you to Dan Hardiker from Adaptivist, who's one of our premier experts when it comes to scaling the Atlassian platform.
Wow. I've not even started yet. Clap at the end. So, hi, I'm Dan Hardiker. I'm CTO of Adaptivist. And I've worked with Atlassian software since Jira 1.0. And I've led hundreds of Atlassian-based projects over the past decade. What follows is a performance talk that I've given all over the world to many different audiences. But I've refined it down to Atlassian-specific aspects. But what you're seeing is not just really about the Atlassian software stack or even Java. It's about performance tuning principles of any given system. So Adaptivist are the leading Atlassian performance tuning expert. And together we have over 5 decades of experience in delivering to thousands of customers all over the world. And our focus is squarely on the enterprise, as that's where we find the most interesting problems. We're known for a few things, such as complex consultancy around our complete ALM model, having both the first and largest number of plugins in the marketplace. But here we're talking about dealing with systems in crisis. As today we're going to be running through Adaptivist's proven methodology for dealing with Atlassian at scale, which invariably involves performance tuning. So this is what it looks like. First, we like to monitor to understand the system. We need to then measure to gather intelligence on the components. Then we can mitigate by analyzing the data with a target in mind. This is really about managing the system. Anyway, enough about us. This is really about you. So I guess there's multiple different types of audience stereotypes out there. So watch the bottom left-hand corner for the icons that are appropriate to you. I've got a lot to get through. We've only got 40 minutes, so we're going to be moving at pace, so buckle up. The slides are going to be available for download after the conference from our website, so don't worry too much about scribbling everything down. As I said, we've only got 40 minutes, so we're only going to be able to cover the core topics of performance tuning, which is a massive topic area. So we're going to cover the whats and the hows. Important things that we are going to be skimming over. Performance testing, which is reproducing the load your system is currently under and identifying the capacity that the system can manage. We'll cover usage profiles and how that can be used inside of a load test, but not the load testing itself. While we'll be introducing tools to solve some of these problems, we won't be diving into them specifically in any depth. So don't expect to find org scripts or a walkthrough of the VM output. While we'll be covering a few common examples of performance tuning in the real world, what follows is really a kickstart rather than a comprehensive list of potential outcomes. But saying that, we have a ton of things to get through. So what are we actually covering? Welcome to the world of the dark art of performance tuning. There's no go faster buttons to push, but by the time we're done, you should realize that there's no magic here. It's always best to define your problem. And before you define your problem, it's always best to define your terminology. So I'll start at the beginning with what is performance? Well, it's actually time. The time taken to perform a defined action. That time impacts the user and gets in the way of them doing what they need to do and holds them back from progressing with their work. Because Atlassian applications are web-based, this usually means a user experience within the browser, which also includes page load time. So what do you hear from your users? We often hear things like, it's slow. Well, thank you for that. We're often told a system is slow and the performance sucks. But does it really? What makes you think that? Is it what the end users are telling you subjectively? What do you think is causing this slowness? Perhaps it was that additional project you added last month, or perhaps upgrading that plugin you did yesterday. But what really makes you think that? Are you sure? Well, hopefully by the end of this talk, you'll feel equipped to answer all of these sorts of questions and give them more confidence that you can deal with these sorts of answers. So beyond understanding what performance is, what affects performance? Well, many things, but primarily it's users. Well, more to the point, lots of users. So let's take a case in point. Most organizations of scale have a lot of users. However, over time, the fortunes of the organization may change, and in turn, the stock price falls. Uncomfortable decisions are inevitably taken, and staff are laid off. In turn, this results in a lower load on the system. As it turns out, this can have a positive impact on the performance of your system. Well, there are many other ways of reducing the headcount in your organization, but we don't particularly endorse movie-style methods. I guess my point really is, users apply load to your system, and you need to understand what they're doing. And not all users are people. We constantly come across automated and scripted interactions and integrations. So what you really need to build is a usage profile, something that looks a bit like this. This describes the different actors on your system, what they are trying to achieve, and by doing what. This is commonly built from access logs, as well as by talking to your users. Usage profiles are really important to understand the current use cases of the system and the scale of each. Make the generation of this usage profile repeatable so you can see how this evolves over time, as it rarely stays static for long. So to recap on how to handle the effect that users can have, you need to build a usage profile and understand what your users are doing. Beyond that, you need to identify the power and automated users. You need to understand who they are and how to communicate and handle them, as well as understanding the business processes that the applications support. After all, Jira isn't just there to be used, it's there to help someone with their job. So, what else affects performance? Well, application administrators, of course. The UPM says I can update. Go on then. It's only a plugin. How bad can it be? No, stop, bad admin. Don't do that. Atlassian applications are highly customizable with an impressive array of extension points. Plugins deliver functionality, and their effects can be profound. All changes to the platform should be carefully controlled, including those from within the user interface. You need to understand and manage your schemes carefully. Think about your issue types. Map out your functionality. Understand the requirements of the service you are delivering. Don't just say yes to everyone and do it. Matt has written an excellent book about these sorts of things, which is well worth a read if you need to understand how to manage these at scale. So to recap on how to handle the effects that application administrators have, understand the user experience that your user base has. And make sure you control the change of the configuration that you have in all aspects. And finally, manage the schemes to make sure that you've got the minimal configuration and you don't have more complexity than is necessary. So finally, we have system administrators. Throw it on a box in the corner. Use the Atlassian installer. What else do I need to do? Well, first and foremost, Atlassian applications are Java-based. Understand and know what that means. Java runs in a virtual machine, and it's a black box that you're ignorant about at your peril. Large pages, generations, garbage collections, NUMA. In order to tune a system at scale, don't just know what these mean, understand them. Windows, Linux, integrate the application container, usually Tomcat, with the operating system and make it work like a native application. Logging, caching, monitoring, reporting, process management, you name it. Make it work like everything else on that machine. Take the path of least astonishment when it comes to configuring the system, and don't make the system administrator behind you have to figure out what you've done and where you've put stuff. Be kind to your future self, as I guarantee you in 6 months you won't remember what you did. Monitoring. So you should be monitoring the health, but not just of the system. You should be monitoring everything. The application has a wealth of information. Average page generation time, garbage collections, database and worker thread utilizations, mail and index queues. Get a feel for the health of the application itself and include those in your KPIs and SLAs. Because just like the proverbial bottleneck, Atlassian applications suffer from contention around the database, network, and disk access, as well as on Unix systems, file descriptors. You should be monitoring and sizing these points of contention and test them thoroughly during any functional change. You need to know what these impacts are going to be on your system. Otherwise, how do you know how they're going to affect production? Hot topic at the moment is let's get rid of the tin and move to the cloud. Virtualization is not that bad, and it can be done at scale. However, it must be well managed, and you have to understand the trade-offs that are going to be taken. One of the key things that any organization that would like to fall under the enterprise banner needs to do is to understand that Atlassian care about their application, as they rightly should. But you need to care about the service you're delivering to your users. This means that the functionality you're delivering to your users and the impact you're having on them by changing it. This also includes understanding the scale that you have to deliver to and validate your assumptions, as you may be dealing with a different scale than you expected, and you can quickly end up out of your depth. For example, the default garbage collector settings are often inappropriate. So to recap on system administrator effects, you need to use the latest supported Java virtual machine and integrate it tightly with the operating system. Monitor all the things. If you can monitor it, do. And virtualize with care, but not with fear. Also, make sure you define the scale that's required, not today, not tomorrow, but where you're planning to be. Understand your limits and your constraints. So that's my definitions. Let's move on to just do it. These are things that you should already be doing, and if not, get them done. And we'll start with a reverse proxy. So we often use Apache. Not that sort of Apache. That sort of Apache. So Apache HBD, and there are others like Nginx, Varnish, HA Proxy. These sit in front of your web server and take load off it to do other functions. One great example is caching. If you're not caching /s, you're doing it wrong. There, I said it. So you need to be able to cache and take all of this load away from the server. That way you're not bothering Java with generating stuff that it doesn't have to, as well as providing cache headers and performing a lower load onto your end users through the browser. SSL termination. Never do this in Java. It is possible. I've never seen it done right. Stick it inside of your Apache, where that problem has been long since solved and it's easy to do. And log. We talked about monitoring before. Log the response time. Time to first byte is what you want, and you want to capture it in milliseconds. I said before, you can use Windows or Linux. I lied. For the application, use a modern Linux. Red Hat, CentOS, Ubuntu, any of those will do. Ensure you can make use of NUMA and huge pages, as the performance benefits can be absolutely profound. Also remember that it's not just the memory of Java you need to worry about, but make sure you have RAM available for OS caching. For example, make sure you can fit all of your indexes into the memory outside of the JVM and any other applications running. I've lost track of the amount of times I've come across a 6 gig VM, and it's got a 5.5 gig JVM sat on it, and the poor operating system is squeezed into half a gig at the end and is screaming for more. All you're doing is hurting yourself as it thrashes around trying to cache. Given you're now running on Linux, make sure you have a minimum of 8,000 file descriptors, up from the default of 1,000 that you would normally find on CentOS or Red Hat. Atlassian applications use a lot of file descriptors for its network traffic and its file access. And we know of systems where they need to have at least 200,000. As we talked about before, monitoring, make sure you understand this bottleneck and you're tuning it accordingly. So, Java. Use the latest and greatest Atlassian-supported JVM, and even minor patch releases can have a profound impact on things like garbage collection. Make sure you're upgrading regularly. And speaking of garbage collection, turn on logging. These are our standard settings. Again, don't worry about scribbling them down. Our slides are going to be available, but I'll walk you through them. So first, we're logging verbosely. We're then capturing the date and timestamps, so we can tie this back to other events that have happened into the system. We're then capturing object promotion data. This enables us to size the generations appropriately, and log all of it into a file. In this case, all that's doing is making sure that the file will be different each time you start the JVM. Remote APIs. Use REST, not SOAP or XML RPC, wherever possible. Still at the point of presenting, there are some Confluence APIs and extension points that you still have to use SOAP or XML RPC to access, but wherever possible, move to REST. You can get almost a 50% reduction in just the communication, let alone all the benefits you get from monitoring and management. Use the Atlassian Bot Killer plugin. If you don't know what this is, go to the marketplace and download it. It's a free plugin from Atlassian. And web bots such as Google use unscripted REST clients can end up creating thousands of sessions, and they'll never come back to use them because they're just one hit. So this works by reducing the HTTP session timeout to 1 minute for the first hit, and then raises it to the original level on the second. This means that the bot sessions expire in a few minutes, not in a few hours. In the case of Jira Atlassian.com, it reduced the heap utilization by 300 meg. Access information. It's not just of use to the NSA, but also to you. So enable access logging, and both application and reverse proxy, make sure you're logging this information, both for tactical information, so you can figure out why things are slow during diagnostics, but also for long-term strategic planning. So they're the things that you should already be doing. Let's move on to the methodology. As whenever you have a problem, only fools rush in. You need to be methodical in the approach you take, and let's run through ours. So the dominating consumer approach, which is championed by Kirk Pepperdine, takes a consumable such as time, CPU, memory, and works out where the biggest wins can be made by identifying the dominating consumer of that particular resource. So let's start with request time. After all, the user experience is king. You need to work out where your time's going. We have caching, or lack of, encryption, compression, transport, which is both latency and bandwidth. You have page generation. And note, this is the time on the server that we often get quoted. But it's only one part of the user experience. You have connection queuing, HTTP spec limits, for example. According to HTTP 1.1 spec, you can only have 2 connections per domain. And so most browsers ignore that to some extent, but it still has an impact. Understand what level of impact you have. Ordering, such as a CSS file that includes a CS file, that includes a CSS file, that includes a JavaScript file, that includes an image. All of these have to be chained. And if you have a second latency between each, it's going to span that out. Browser rendering. If you have a complex page, understand how your browsers are using the data that comes to them. If you're still stuck on IE6, you really need to understand that. But let's say that you need to dig into the page generation time, because many things affect this. So we have things like filters, authentication and authorization, especially if you're hooked up to an LDAP crowd or other external system. Content rendering, people sticking 1,000 macros on a page. Searching, that's both the indexing activity, such as indexing of a PDF, but also the searching itself. Complex JQL queries can sometimes cause you a lot of issues. Database queries, plugins, and external dependencies all have the impacts you'd expect. But you need to figure out which of these factors are causing you the most pain. But you need to first find out what your average page generation time is. You can obtain these from the logs and average this over a given time window. And you resolve it down to the usage profile that we saw earlier. And for each of those use cases, you want to understand the average page generation time for each. You can then track that over time and see whether it's getting worse or better. But you understand what the system is like. So when you come to needing to tune a system, you know what's not normal. You can also use this usage profile to scale your load test setup, so you can apply consistent and predictable and representative load against your test system. Atlassian provide a great out-of-the-box grinder scripts as well as some JMeter scripts. However, you need to make sure they're tuned for your particular usage case, as it's rarely the same as out of the box. Time boxing. not quite that sort of time boxing. What I'm really talking about is breaking the system down to a bunch of components and understanding how the time flows and is lost in it. For example, a request comes in and it takes 60 milliseconds to transport into Apache. 50 milliseconds of work is done decrypting that traffic. And as caching is within Apache, there's no latency in actually talking to itself, but the caching itself takes under a millisecond. From there, there's about 3 milliseconds to proxy that between Apache HBD to Tomcat, where the request itself takes 790 milliseconds to actually generate and return. The response of that may take 5 milliseconds to get back into Apache, and again, it may take less than a millisecond in order to be cached. Again, we're talking inside of Apache, so there's no latency, but encrypting that response takes about 50 milliseconds. And all in all, it's 60 milliseconds until the first byte is transmitted back to the client and the data starts to be moved. In total, we're talking about 1,020 milliseconds. And you can see how that breaks down. With 3/4 of this is being spent in page generation time. This sort of information is valuable because it tells you where you can get your biggest win, and you would then go and break that 790 milliseconds down further to see where you can get the biggest win. But how do you go about getting these statistics? Well, in this case, we started with Chrome Developer Tools, which has broken time down into DNS lookup, the TCP connection, the SSL overhead, the request transfer, the time waiting for the response, and the response transfer itself. And here we can see that half of the time has been spent with SSL, but in total, it's only about 350 milliseconds. So we're only going to save 1/10 of a second at best, maybe. Is it really worth us trying to optimize that? Those are the sorts of questions you can answer. At the higher level, there's request detail. And here you can see in the column under size where it's got the data from the cache. You can see caching both happening within the browser, which is those, and also within the proxy, when you get a 403 response. Firefox and Internet Explorer and other browsers have similar tooling. So work with the browser that your users are using and make sure that you're testing appropriately. Let's say you need to go a bit further. You need to dig into the logging. You've got both access logs from Apache and from the application. And the time you're really looking for is the time to first byte. This encapsulates all of the components behind that particular block. And if you need to break it down further, for example, you might want to understand what amount of that time is taken up by database requests. Well, we can use something called log4jdbc. This is a wrapping logging JDBC driver. And you sit it around the JDBC driver you're already using and will log a bunch of extra detail for you. Each database server is unique and has its own tooling. And you usually get those driven by a DBA, but you can determine the quantity, type, and duration of the queries that are happening and take all the information you can to get a fullest picture as possible as to what's really going on. Make sure you question the statistics you get and make sure they're valid. So let's say we've broken it down and it is the application that is taking up all the time. Nothing outside of it. You need to do application execution profiling. Atlassian have a built-in profiler, but there are other ways of doing it. You can use thread dumping to get a first cut analysis. There's profilers like YourKit and JProfiler, or you can use Atlassian's inbuilt so-called poor man's profiler. If you need to go and do more targeted timing, you can build a plugin using aspect-oriented programming and use point cuts to find particular parts of the system to time. Make sure you're using a library like perf4j to do your statistical timing, as you can quite often get inaccurate statistics when you do it yourself. For example, sub-milliseconds timing is usually unreliable, so offload it to a library like this, which has solved that problem. Useful plugin module types you might want to implement to do this sort of things. You want to use filters and transformers. There's a few others, but you can get into the inner workings of the application to get that timing quite granular. But really, this all boils down to the CPU, as this is the resource that gets work done on the system. You should understand what's going on with the processing unit, as everything follows on from there. Because the first question you always want to ask is the CPU in use? Because you can use top to find it out, but if not, why not? What's holding back the CPU from doing its work. I/O weight could be memory, network, or disk. You can use vmstat or iostat to find that sort of thing out. Or it could be locking. Well, locking is one thread or process waiting on another. And again, you can use vmstat and looking at the runnable and blocked queue numbers. Or you could use JStack on the Java process, and it'll give you a breakdown of the threads and what's waiting on what. But let's assume the CPU is in use. You need to know by what. Again, you can find top and vmstat to break it down. But let's say kernel times are high. It means the operating system itself is using up all the resources. This is typically because it's swapping. It might be spinning on sockets. vmstat is your friend, as is a friendly, experienced system administrator. On the other hand, it could actually be the Java process. That's a little bit better. But saying that, you want to know if it's a JVM or the application itself that's taking up the time. JStat, JMap, garbage collection logging, these are all your friends here, and you might also want to use Visual VM. But assuming that the JVM itself isn't stopping the world, this leaves the application logic using the CPU. This is good. This means your application is buzzing along, doing the number of crunching activities it's been assigned to do. Execution profile analysis can help here. Again, using things like JStack to take thread dumps, Atlassian's profiler, YourKit, JProfiler, targeted timing around macros. It'll give you a better breakdown of the actual work it's doing. Less than 10% of our cases actually fall to here, so make sure you're starting at the beginning and don't assume this is where you'll end up. Okay, so we've run through a definition of performance. I've told you what you should have as a basic starting point, and I've given you a methodology to follow. But let's go through putting it into practice. And I'll give you a very common problem statement that we get a lot. Anyone else had this problem? Not that useful. It's not useful to you, and it's not that useful to us either, especially the bottom word. It's slow erratically, but you need to define that a bit more detail, because you need to know where to go, what sort of logging to both check and apply, and when to start your investigation. So let's create a better problem statement. So every so often, the system becomes unresponsive, but given some time, the system recovers. From here, we need to do a system analysis. In doing so, we've seen that the kernel times are low, which means that the operating system is not stealing resources, and it's not swapping. The application is still not getting on with its work. However, there is a correlation between the stop the world GC activity and spikes in the user experience. So we have a culprit. We have a suspect. From here, we need to go and confirm what we've done, and we need to go and do some investigations to garbage collection analysis. So we can use grep, sed, and awk. These are great for giving you a first pass analysis on log files to see, are you going down the right path? It gives you simple statistics. You can then go into more detailed analyzers. There's HP JMeter. Note this is not the same as Apache JMeter. Apache JMeter is a load tool, and you don't want to be adding more load to your underperforming system. GC Viewer is another visualization tool, but the one that we use most is JClarity Sensum. The graphs that you're going to see have all been generated by this. So the standard GC chart that you see, this is a real system. This is over a 5-day period. It's Jira 5.1, 15,000 users, thousands of projects, 2 million issues. I think it's now more closer to 2.5. 1,000 custom fields, 100 permission schemes. There is over 300 terabytes of object allocation going during this time. Yes, terabytes. During this time, there's been over 480 full garbage collections, each lasting between 50 and 30 seconds, broadly speaking. And the average young garbage collection is just under a second. Digging just a little bit in, we found that it's using the default garbage collection settings. It's effectively out of the box. So this is what happened after we spent a week tuning it. No changes other than the JVM parameters have been made. It's still the same load. It's still dealing with that 300 terabytes of allocation. However, over the same 5-day period, we've now got less than 20 full garbage collections. They're now lasting a little bit longer, between 20 and 30 seconds. However, the average young garbage collection is up now between 1 to 2 seconds. The overall user experience is actually slightly slower by about 1/4 of a second or so. But the intermittent stoppages are far, far less frequent, making the system much more reliable. Users have now regained confidence that they can get on with their work and it's not going to be pausing every 5 or 6 minutes. Of course, 25-second pauses every few hours is far from ideal. We're now still working on significantly increasing the heap size, so we have longer pauses, but that they happen at more controlled times, such as out of hours when no one's using the system. So this is what we found. Again, use the latest Atlassian supported JVM. Just doing that gives you a performance boost. You need to understand and size the generations properly. If it's too small and you're getting premature promotion, and too big and you'll be squeezing the other generations and or applying unnecessary garbage collection pressure. Understand what the generations mean and how they actually function. Make sure you're using the right garbage collector for your garbage profile, as there isn't one size that fits all. And make sure that you use non-uniform memory access and thread local allocation buffers. It wasn't possible here, but we're working on that. And stop swapping. You're taking something from RAM, which is nice and fast, and sticking it on disk, which is nice and slow. And paging in and out is not what you want to be doing. You can use large pages and huge pages to stop the swapping, but what it effectively does is pin it into memory. So if it has to swap, it will swap it all. At least you'll know about it. So from here on, we need to upgrade the operating system so we can get the non-uniform memory access and support so that we can get the performance boosts that having local memory to the CPUs gives. We need to repeat the testing to measure the performance impact of the change that we've just made. And critically, we change only one thing at a time. Otherwise, we cannot tie which change has what impact. We repeat this cycle until we either run out of money or time, or get an acceptable result. If you get to the acceptable goal, then no point in continuing. Beyond that, don't forget to look at the load. Here we have 300 terabytes of allocation. Is someone doing something that's less than ideal? Almost certainly. But as we only have 40 minutes, this isn't an area we're going to be specifically covering. Here's the second one. This one is far, far worse. This is not people saying I'm being slowed down from doing my job. This is saying I cannot do my job. This is when people get sent home. And this costs businesses money. Businesses don't like that. Because of that, you can end up with anti-patterns. So under pressure, you can only do what you know. And surprise, surprise, stress is stressful. And problems in production are absolutely no different. If you're interested in the biochemical effects that stress can have on a team, well, read Robert Sobolski's Why Zebras Don't Get Ulcers. It's a great dive into human biology and how you really can only do what you know when under pressure. So if your business is losing $1 million an hour while the system is down, actions inevitably get taken without tested evidence. You end up with quotes being bandied around like, doing something is better than nothing. Well, the problem there is you're then pinning your solution up as this is what we do. If it makes it worse or doesn't make it better, your users are going to reduce confidence in your ability to actually solve the problem. With this, you end up with a shot in the dark, because conclusions are drawn from the partial data set you have available, and changes then get implemented rashly. And a knee-jerk analysis is then taken. For example, here we see an out-of-memory error appearing in the log. The system is garbage collecting heavily, so it needs more memory, right? So we doubled the JVM heap. Unfortunately, it has absolutely no impact, and the problem recurred just as before. That's because we didn't find the root cause of the problem. We found a symptom, and we were lucky it didn't cause a larger impact. But what was missed? Well, we measured the stability for the previous 2 weeks, and the system had been stable for that whole time. The usage profile has not significantly varied over that time, so we know the external factors that are coming into our system are roughly the same. Something must have changed within our system. So, all the HTTP threads, once we'd done a dump, we noticed that we're waiting on the database connection pools, and all of those threads had a common code path. So what could we have done better? Database connection pool monitoring is something that you should have picked up by now, because Jira can make over 10,000 database queries per request. In some cases, on a fresh Jira with no caches, we've seen 40,000. Access to the database in a timely manner is critical. We need to understand what's going on within the database connection pool. This could be DBCP within Tomcat, or C3PO within each application. Where are the connections going? What's using them? Long-running queries, or is it connection leaks? This is what we're looking for when we're monitoring. Something like this. So walking from the bottom, the in-use shows you the checked out database connections. And these are the ones that were in use at the time that the monitoring metric was taken. Used recently tells you those that have been checked out and have been used in the past minute, but not right now. Checked out, the orange area, these are those that have been checked out from the pool, but haven't been used in the last minute. This is bad. They should have been released back. You then see the available that's checked out from the pool, and up to the top line, you see the maximum pool size. And this is where we can burst up to. If we grey out the available connections, which we could use, we can see where the resources usage actually is. Note the red area at the top? This is what's waiting on connections. These threads are blocked. If we grey out the normal usage of the system, you can see that there are a large number of connections checked out without actually being used. If these had been available to the pool, the threads waiting would have been able to access the database, which means that those requests would have completed faster. 3 approaches from here. We can create a bigger pool, but we don't know whether that orange area is just going to get bigger. We can address what's checking out the connections from the pool, locate those by thread dumping, and here that's probably what I would do. Or perhaps it could also be that a network or server issue is existing and it's running slow, and the problem is somewhere outside of the application. So it turns out that the latest release of Team Calendars has a new Jira integration in a point release. This has caused an increase in database activity and is a functional change, which impacted the bottlenecks within the system, which in turn altered the system requirements. Because of that, a larger database pool was needed, and we calculated this to be 250, which is up from the 30 it was before. And we did that based on the analysis of the evidence that was provided. It's important not to just guess at a bigger number. You need to be able to justify what you come up with. We didn't just make it bigger. So, the outer memory was actually caused by each thread. Because each thread was getting locked, and the larger amount of memory was taken up in each thread, it meant that as each thread was getting blocked and the pool was growing, the outer memory error occurred because it was just growing exponentially. This problem would likely have been caught in a test system as it was a scheduled work in the back and just grew over time. However, the load test hadn't been used and we didn't test the functional change, and so that's where the problem was rooted. So that's performance tuning. But there is a bigger picture to consider. This goes beyond how to just measure the performance tuning and implement defensive measures. You see, at the cellular level, performance tuning is really about the application itself, but it's not alone. The application is just part of the service that you deliver, and the performance is just one component of a service's availability. This isn't about performance. This is about being able to access a tool to do your job. Service availability isn't just one component, it's just one component of an operational system that support people within your business. But if you look at the whole picture, we see that ALM, or Application Lifecycle Management, is actually about helping your business deliver. This is about supporting the people and processes in your organization that are enabled by the tools and technology. This is about why using Jira makes bread 5 cents cheaper. Adaptivists have a methodology for encompassing the ALM process. We call it complete ALM, as if Arnie developed software, he'd use Adaptivist Calm. So sometimes nobody is available, time is too short, downtime is costing money, and you need an external opinion. Sometimes you need a framework to work by. Sometimes the problem is too big, and you just need a helping hand. Sometimes you need an Adaptivist. Well, actually, we're one of a number of Atlassian enterprise experts and exist in a vibrant ecosystem that support Atlassian through their partners. Talk to us or Atlassian to find the most appropriate expert to meet your needs. Anyway, if you only remember one thing, you must JFDI and be methodical. No, sorry. There's two things for you to remember. You must JFDI and be methodical and measure. Amongst the things for you to remember, I bet you didn't expect an inquisition. Monty Python references aside, there really are three crucial things to managing a system. You need to ensure you have your bases covered. Just get it done. Be methodical whenever you approach a problem. And make sure you measure, never guess. As Einstein said, if I had an hour to solve a problem, I'd spend 55 minutes defining that problem and 5 minutes thinking about the solution. This is because when you understand the problem, the solution becomes obvious. So from here, if you want to learn more, as Ken said, we have a performance tuning lunch table. There's a ton of folks from Adaptivist around here. You can't miss us in our branded shirts. We'd be more than happy to help you with some advice. There's also a LinkedIn group for performance tuning, which is run by Claudio Umbrella from Autodesk, which is well worth joining. And there's a lot more information at the Atlassian Enterprise Resources, which you can find at Atlassian. We go big. One last thing. If you knew all of this and we bored you, or if you're just really, really good, we're hiring. Thanks.
Thank you very much. Yeah, that was subtle. That was awesome. I assume there might be a question or two. We have about 3 or 4 minutes. We could probably handle a couple of them. And then again, we'll follow up more afterwards. Anybody got a question they want to ask? I see a hand over there. Lee's got you.
Hello, can you hear me?
Oh.
So, in your Atlassian deployments in these big organizations, have you guys tried to, or what's been the success rate if you've tried it to replace the hard disk with SSD, and how has that impacted performance at all?
So it depends. So if your latency to disk is what's causing the problem, that's often you're talking about indexes. That really is a key issue. Then definitely, so our broad advice for Fisheye and Crucible is if you're not using Fusion IO, you're doing it wrong.
Yeah.
And Fusion IO is a card that's basically a fast SSD. And if you're using it at scale, you need to be doing that. You'll find that actually, if you have the operating system caches as big as the indexes, it'll actually cache the indexes within memory, which is what I was talking about before of making sure your operating system has enough room to breathe. So figure out where the bottleneck is, and if the bottleneck is around latency to disk, absolutely.
Okay, we'll go over here on this side.
We've had the exact same problem for many years with the team calendars, or not many years, many months. And we've also determined that it's the link between the size of the database connection pool, but we have no idea what to make the settings. And you said, don't guess, base it off data, but I don't understand how would I ever determine what the right number of connection pools is, like how big a database pool should be?
So part of this is understanding the application, and you really do need to lean on an expert or someone internal in your team who is an internal expert in Atlassian software to understand this. But what we know is that each database each possible HTTP worker, in this case 200, could have needed a database connection. And it's only going to work in serial, so it doesn't matter. So we had one for each, that's 200. We also noted that Jira itself was using about 10, just in the background. And that the growth for the plugins we had installed was about 20 to 40. So we made that 250, and then we were able to then see that trend.
And then a follow-up question. I understand that the database connection pool is linked to how many threads you should have or how many processes you should have. Do you have feedback on that? I've heard they should be roughly equal or one double the other.
So if you're evaluating Confluence, I can tell you, or Jira, I can tell you exactly what to set it to. At scale, you need to understand what your bottlenecks are, because your usages will be very, very different. Your plugins and your profile will look different to the next. We never come across two identical systems. There are general rules that you can follow to figure that out, such as what I just mentioned, but there's no number that you set. You don't find this number and make it that number. It's a much more complicated process. However, you need to make sure you follow that data so you do come to the right number, rather than just saying, we'll just make it bigger.
Okay, we'll do one more over there in the corner, and then we'll take it to the tables after that.
Given that Jira cannot scale horizontally today, I was wondering, what's the largest or maximum number of concurrent users that you have in a single instance?
So that depends on what the users are doing. Again, if you're having Confluence as an intranet, which has a lot of static content, you can cache that heavily. And you could run to tens of thousands. You can make it a public website and have millions of connections if you want. If actually you're running a service desk and there's a constant churn of data coming in, then you have to be a bit more careful. In fact, we had someone talk to us about, sorry, just checking time. We had someone talk to us about the new Jira Service Desk plugin. And they were really concerned about what impact that's going to have on their performance. Because it's not just Jira's performance there, as while you're filling in the issue to log a support request, it's doing hits against Confluence to get the knowledge base entries, but it's doing that as you type. Turns out it's between 5 and 10 hits on average that's going to put onto Confluence. So we add that in, and it's now taking 2,000 requests a day for support requests. That's now an extra 20,000 hits on Confluence each day on an already underperforming system. You need to understand what your particular use case is and then how to tune that. So in this case, we're able to continue to use the Service Desk product by reducing that so it only completes a second after you stop typing. And therefore, you still get the information, but you don't get the load. And by tuning those bottlenecks, we've not reached a limit yet. We've always managed to get to a point where it's acceptable.
All right, I think we're going to leave it there. Thank you guys very much. Go get some food out of the trucks.
Okay.
Thank you, Dan.